Okay, thank you so much for bearing with me. I'll just get started right into the presentation right now. I was having some technical difficulties with the other one, but I think it's good now. So, okay, so thank you for joining me on my presentation on how to program the Amazon Echo with Python. You know, let me just get a chat window open. So if there's any other difficulties, you can just type it in the chat and hopefully I'll catch it. So open a live chat window. Okay. So yeah, thanks for joining me to show you how to program the Amazon Echo with Python. Before I start, I'm just going to give a quick demo of a very simple Hello World style skill that I wrote. Start demo.
Hello, PyLadies. Welcome to today's presentation, Flask-Ask, an Alexa Skills Kit framework for Python.
Okay, and so I'm using right now the Echo Tap, and I'll talk more about how this particular device works in a second. But now I'm going to go ahead and start the presentation, and I saw that you can hear me, thank you. And I will go ahead and show the slides for that. So I'm going to share my screen. And I will, let me just ask real quick. Can you see my screen that where I'm typing? Okay, great. So what I'll do is I'll just start going through the presentation, and as I'm going through the presentation, I'll probably check back just to make sure that nothing's going wrong. So I might pause throughout, but I'll go ahead and get started. So before I start, I want to tell you a little bit about myself. My name's John Wheeler, and I live in San Diego, California. I've been programming professionally for 16 years, and I created Flask-Ask earlier this year. I'm self-employed, and 5 years ago, I developed software as a service that helps eBay sellers. I'm an independent programmer not affiliated with Amazon, but they've been supportive of Flask-Ask, and we put out a guest blog post on their Alexa blog last month. Now that you know about me, I want to go into why I'm excited about programming the Amazon Echo. In 2013, Warner Brothers put out a movie called Her that you might be familiar with. In that movie, Joaquin Phoenix buys a computer that carries on conversations. The computer's voice is played by Scarlett Johansson. What starts out as a novelty evolves into a relationship between the two with empathy, jealousy, and real love. Of course, artificial intelligence has not advanced nearly that far in real life, but the movie gives glimpses into how voice user interfaces might evolve in the future. VUIs, as they're called, might be in every home, every car, and even in public places. Since conversation is the most natural way for humans to communicate, it makes sense to pay attention to this technology and follow where it goes. So here's an Amazon Echo, and it's currently the state-of-the-art in ambient voice-based computers. Ambient means that unlike Apple's Siri, which used to require holding down a button, Alexa responds by name. Alexa is the default keyword to activate the Echo. Being able to work with a computer without using your hands is a big deal. That one simple feature, it turns out, makes all the difference in terms of usability. Now, Siri doesn't require pressing a button and can be invoked with Hey Siri. Apple is also opening up Siri to be programmable. In addition, Google is coming out with their own technology called Google Home. All these are built on advanced machine learning and natural language processing technologies. The machine learning requires immense data sets that only companies like Apple, Amazon, and Google have access to. The practical use of this advanced AI and big data is exciting, but there's even more reason to start programming the Amazon Echo, and that's that we're just getting started and in the primitive stages of the technology. Here's what I mean. I'm going to just do a real quick sanity check to make sure that the presentation's going okay. So it's gonna, okay, looks like everything's going okay. You didn't put anything in the comments, so I'll just keep going. Okay, so I was saying that I think that this is the future, and I'll just kind of give an analogy to past events. So in 1984, Steve Jobs introduced the Macintosh to the world, and it started a personal computing revolution. Most would agree that that revolution is still in its infancy, but one thing is clear for sure. We never anticipated the shape of things to come. There's a multitude of form factors, new and complex manufacturing processes, and social networks and sharing economies that have built up around personal computing. The Amazon Echo is in the same position today that the Macintosh was in 1984. It's an early unit and the impact isn't fully understood. It makes sense to get in early to take part of this coming revolution. So that's why you should want to program and learn the Amazon Echo. And before I get into how you can do that with Flask-Ask, I'm going to talk about the current landscape, starting with the hardware. These are the current Echo devices from left to right. The Echo Tap is a portable omnidirectional speaker. The device I'm using today is an Echo Tap. It does not feature ambient technology in that you have to push a button to activate Alexa. I haven't used the Fire TV, but it also has Alexa built into it. The last two devices are the Echo and the Echo Dot. Pardon me. They both feature ambient voice technology, and the difference is that the former comes with an omnidirectional speaker, and the latter is meant to plug into your own speaker. The Echo Dot can also use Bluetooth. There are currently two ways to program the hardware, and we'll be focusing on one of those today. The Alexa Voice Service, or AVS, is for embedding the Alexa experience in your own hardware. Amazon just released an intercom system called Nucleus that uses this technology. The Alexa Skills Kit is for programming voice user interfaces or skills. For example, you can say, Alexa, ask Lyft for a ride, and it will call a driver to pick you up. We'll be focusing on the Alexa Skills Kit. Flask-Ask is a Python framework that makes working with the Alexa Skills Kit easy. Before moving on to how the Alexa Skills Kit works, I want to mention Amazon has a skills store that works similarly to how the Apple and Android app stores work. In addition to using your mobile phone or web browser to install skills, you can also ask Alexa to install skills. For example, you can say, Alexa, enable Lyft. This makes it easy for your users to install new skills and allows the skills to spread easier by word of mouth. All right. I'm going to just check one more time to see if there's any questions. Okay, great, great. Back into the presentation. Okay, so now I'm going to go into developing how the actual skills work conceptually. So to explain how the Alexa Skills Kit works, I'm going to develop a simple program that adds two numbers. To activate it, I'll say, Alexa, ask demo what's 3 plus 5. There are three concepts you need to understand to know how the natural language engine processes the speech. Those are skills, intents, and slots, and I'll go over each one of those now. So with the sentence that I mentioned, the word demo is going to be the skill. The skill is like a program. The lift skill is identified by its name too. You can only have one skill with a given activation name installed at a time. Each skill can contain one-to-many intents, and those intents can work together to carry out conversational flows with users. Intents are like functions. They tell Alexa to tell, this is the intent slide, and these are like functions. They tell Alexa to tell your skill to execute a certain piece of logic. Here, Alexa will know to execute an intent in our skill called add intent. I'll show you how intents are configured soon. The 3 and 5 are interchangeable with other values. Those values are called slots, and they're like arguments. And our program will map those values to slots called X and Y. So when you speak to the Echo, the Alexa service sends your skill JSON over HTTP. Here you can see a portion of that JSON payload. Each skill can only have one-to-many intents. Here, add intent is being passed to our skill with slots X and Y, and the values 3 and 5. So I'll just keep that up for just a second so you can look at it. You can see that there's an intent, and it's got the 2 slots. You could also have more intents. So there could be a multiply intent and a divide intent and a subtract intent. And all of those intents together make up a skill or a program. Once our skill receives that payload, it has to parse it, operate on it, and return a JSON response. Here is the business piece of that response, but it can get more complex. We just want it to repeat the sum back to the user. Now that we've gone over the JSON request and response formats, I'll show you how Flask-Ask makes working with them in Python easy. So here, a Python decorator maps add intent to a function named add. The function itself can be named anything, but by default, the slots must be named the same as the slots in our configuration. When I do the live coding demo, I'll go over that configuration. Flask-Ask automatically parses the JSON request and maps it to your Python function. It also cryptographically verifies a portion of the request that I didn't show you called the request signature. This way, you can ensure HTTP requests coming to the skills endpoint are from the Amazon Echo service. Flask-Ask also helps with error handling and building JSON responses. Here we're going to return a simple statement that just says the sum of our 2 numbers. Okay, so now that you know the conceptual model, I want to show you the flow of events so you can see how it physically works. And then we'll go into the code demo. Okay, so first, the user speaks to the Echo, and the Echo streams the speech in real time to the Alexa Cloud service. Based on the user's account and the skill's activation name, the Alexa service looks up the skill's configuration. This information includes the HTTPS endpoint the skill is located at on your server. Next, the Alexa service sends your skill JSON request over HTTP. Your skill operates on that request and sends a JSON response back to the Alexa service. Finally, the Alexa service interprets that response and speaks back to the user. Okay. So now I will go over how it works. I'll do a demo of the code. So I'll go through the full configuration, and I'll just kind of start from scratch. So you can see there's the code that I had before, and I'll just go over it. So the first thing that I want to show you is how to actually configure the skill in Amazon's portal. So here is the portal right here, and I will just go ahead and I'll delete this skill so we can start on a new one. And so I'm going to add a new skill, and I'm going to call it demo, and I'm going to give it the indication name of demo. And we don't have to go through all these screens. You can see it's kind of like a wizard. First you give it the skill information, and now it's going to ask for this interaction model. And this is going to use some JSON that I haven't talked about, but I've put the source code on GitHub, and I'll send links out for that. So it uses something called an intent schema, and here's what that looks like. It basically is another piece of JSON that just defines the specification of your intent. So I'll paste that in. And then the second piece of the configuration is this sample utterances. And this is how Alexa knows which of your intents to invoke based on the speech that you say. So you have to kind of configure different permutations and anticipate what your users are going to say. But Amazon also provides built-in intents for the most common of those to make it easier on the developer. So I'll paste that in. And now when I hit next, it's going to bring me to this endpoint configuration page. Now, the really nice thing about developing with Flask-Ask is you can use a program called ngrok. And what ngrok does, I'll launch it. The command you give it is ngrok http 5000, since Flask launches on port 5000. And what that's going to do is it's going to create these random endpoints that you see right here. And what those endpoints do is you can give those to the Alexa service, and the Alexa service will forward its JSON to those, and then ngrok will forward that data to your local host program. So it's a secure tunneling proxy is what it's called. And what you do is you just copy this endpoint right here, paste it right there, and click HTTPS and leave account linking set to no. And then we're going to choose this second option, which just says that the development endpoint is a subdomain that uses wildcard certificate. And now we're ready to test. That's the only configuration you have to do. And so now I'm just going to start writing the program. I'll just do a hello world first, and then I'll write the add program. So to use Flask-Ask, we import Flask first because Flask-Ask is a Flask extension. And then there's also question. We're not going to go over how question works, but we'll use ask and statement. And let me also import logging. Okay, and so now I'll just instantiate Flask as normal. And for extensions, you pass in the app when you instantiate the extension. And for Flask-Ask, you have to give it basically a route that it's going to go to. And this is nice. So if you're actually building a Flask app, you can add on voice capabilities by giving it a single route, because the Alexa service will forward all requests to a single route. Okay, so then we'll just say log. Okay, and I'm just going to configure Flask-Ask to give us some helpful debug information while we're programming with it. And now I'll write the function. So I'll say welcome. Okay, and so in order to map this, we're going to use what's called a launch intent. And when you invoke an Alexa skill but without passing in any sample utterances or of those speech, like to add the two numbers, when you just say launch skill, it's going to invoke this launch request right here. So let's just make sure everything's working. And I'll say Flask run. Okay, and so now I'll try it out. It might not work, but we'll give it a shot. Start demo.
Hello, world.
Okay, so that's how the launch request works. And the really nice thing about ngrok and Flask is you can do it. You can, write your code without recompiling or redeploying to any servers. So just make one modification. Start demo.
Hello, world to PyLadies.
Okay, and now continue on with our add intent. Oops. ahead of myself just a second. So text. Okay, so, and then I'll say the sum equals x plus y. And this has a bug in it that I'll go over, but just to kind of show you how this is working. What we've done is we've created an intent called add intent that we configured in the Alexa service, and now we've mapped that to a function called add, and we pass in x and y as the slots. We're computing the sum of those, and then we create a variable called text, which is going to speak the sum back to the user. So let's give it a shot right now. Tell demo to add 3 plus 5.
The sum of and 5 is 5.
Okay, so I did one thing wrong. 1 second, let me see. Sum of, let me just do this. Sum is format sum. Try it again. Ask demo, what's 3 plus 5?
The sum is 35.
Okay, so that's the bug that I was talking about. And what's going on is when it evaluates x plus y, it's doing string concatenation instead of addition. And that's because those parameters are coming in as strings. So Flask-Ask helps you with that by providing this convert parameter that allows you to convert to different data types. So I'll say x is an int, and y is an int. Okay. Tell demo to add 3 plus 5.
There was a problem with the requested skills response.
I'm sorry, I gave it the wrong utterance. Ask demo, what's the sum of 3 plus 5?
The sum is 8.
Okay, so that's better. All right, so that is the live coding demo. And real quick, I'll switch over to why I set up the logging. And it just lets you see the request payload. So you can see here that the requests are coming through with the slots. And you can also see the responses that are being output. So that is how Flask-Ask works. So now let me switch over to the Hangout. And I'll say stop. All right, so I wish there was a way that you could ask me questions directly. If you have any questions, you can go ahead and type them into the chat. Otherwise, if you want, I'll put my email in there. And I'll also put some other links. So thank you so much for watching this demo. I really, really appreciate it. And please contact me if you have any questions at all. Okay.